Algebra 2 students, in this video today we will be looking at the characteristics or some characteristics of polynomial graphs, okay? We will be learning some other characteristics later on in this chapter, but we are going to look at some characteristics today. Your heading, of course, is obviously characteristics of polynomial graphs, lesson 9.2. And be sure and include today's date. Okay, be sure and include today's date. And here we go. Please understand that we are not going to actually graph polynomials in this video, okay? In fact, let me just stop and say this right now. In the first lesson of this chapter, lesson 9.1, you were taught that polynomials look something like this. Something like that, okay? Well, what we're going to do today is we're going to add an f of x equals, and now we have polynomial functions, okay? Polynomial functions, so no big deal. Nothing earth-shattering, but we're now going to have polynomial functions, okay? So, if I asked you to graph this, you need to learn some things about it. Now again, we are not going to graph them in this video. That'll be later on in this chapter, okay? But we're starting to lay the foundation for graphing polynomial functions, okay? So the first thing we have to do is learn some characteristics about these functions. Now, we're going to graph these later on before the chapter is over, so if you notice that we are skipping some of the problems in this section when you do your homework, rest assured we are going to come back to these problems. We are going to graph polynomial functions. Today we are just going to learn some key characteristics of polynomial graphs that will help you understand them better and help you graph them better later on in the chapter. We are going to look at three types of characteristics today. First, kind of generally speaking, we're going to look at what they look like, okay? What does a polynomial function graph look like? Secondly, we're going to learn how many turns they take, or at least a maximum number of turns that they take. I'll explain that later. And lastly, we're going to learn what direction they are going on the left and right side of the graph. Okay, so having said that, here we go. Let's jump into this. This might sound a little confusing, but it's actually quite easy. I will explain all this to you as we go along. All right, here we go. Now, take notes on this however you feel necessary, okay? But a polynomial graph can have many turns sometimes, okay? It might only have one turn. It might have no turns, okay? But a polynomial graph takes smooth, rounded turns. When you graph a polynomial, you would never see something like this. Like that, okay? A sharp turn. All of the turns will be smooth, rounded turns. You might have a really high turn, then a couple little low turns like this, then it comes back up again. I mean, they come in all kinds of shapes and sizes, depending on whether it's a first degree, second degree, third degree, fourth degree, fifth degree, sixth degree, seventh degree, etc. Okay? And remember, in the first lesson in this chapter, we learned about degrees of polynomials. Okay? So understand, it's not like graphing a parabola where we know it's going to be, or a quadratic where it's going to have a parabola shape, okay? It can have many turns, not many turns, but the main thing you need to know is it'll take smooth, rounded turns. Okay, that's number one. And it can be really narrow, really wide, okay? Doesn't really matter. And then also, eventually the graph will take its last turn, and it will start going down, or it'll start going up, okay? And it will continue going down, or it will continue going up. So eventually that will happen. A polynomial graph can only take so many turns, okay? So that's the general shape of what a polynomial graph looks like. I guess what I just taught you is that the general shape of a polynomial graph is that it has no general shape. But we do understand it's going to take smooth, rounded turns, okay? Alright, moving on. Next, let me teach you how to know how many maximum turns a polynomial graph will take. Guys, think about how much that helps you when you're graphing. If you're graphing a polynomial function and you know it only takes 2 maximum turns at the most, and it goes something like this, and it's on its way down? Well, it already took a turn right here. It already took a turn here. So you know it's going to continue going down. If you know that the graph only has a maximum of 2 turns. Do you see what I'm saying? So there is a way to look at a polynomial function and know the maximum number of turns it's going to take. Okay? It's actually quite easy. Find the degree of the polynomial, subtract 1 from it, and that is the maximum number of turns a graph will take. I would like you to copy that in your notes. That is very important. Please copy that in your notes. Find the degree of the polynomial, subtract 1 from it, and that is the maximum number of turns the graph will take. So for example, while you're copying this down, just listen to me. Let's say we had a 8th degree polynomial, okay? 8th degree polynomial function. We'll subtract 1 from that, and you'll get 7. Now, are you listening? Listen carefully. That does not mean the graph will take 7 turns. That's not what it means. It means it will have a maximum of 7 turns. In other words, it might have 1 turn, or 2, or 3, or 4, or 5, or 6, or 7, but it will not go above 7. Okay? So this is how you find the maximum number of turns a polynomial graph will take. Find the degree and subtract 1 from it. That's really helpful. You need to know that. So let me give you a couple of examples, and you take some really good notes on these, alright? Okay, here's the first one. Now, my degree is 5. Okay, that's the highest variable exponent I have. So, I have a 5th degree polynomial function. Got it? So what do? I subtract 1 from that, and I get what number? 4. So if I were to graph this function, it'll take no more than 4 turns. The maximum number of turns it can take is 4. Now, am I telling you it will take 4 turns? No, it might take 4. It might take 3. It might take 2. It might take 1. But it will not take more than 4 turns. Okay, isn't that easy? Find the what? Degree, and do what to it? Subtract 1 from it. Okay, that's it. Alright, moving on. Now let's try another one. Now when you look at this, don't think the degree is 2. Okay? The highest exponent is the degree. So look for the highest exponent. Once again, it's a 5. That's a coincidence. So we have a what degree? 5th degree. So if I have a 5th degree polynomial function, subtract 1 from the 5, and you get a 4. So the max number of turns, if you were to graph this, is 4. It might take 3 turns, might take 2, might take 4, but it will not go over 4. Does that make sense, guys? So we've learned a couple things so far. We've kind of learned, generally speaking, what a graph looks like. It takes smooth, rounded turns, and eventually it will continue going up and down eventually, and not take any more turns. And then secondly, we've learned how to find the maximum number of turns. Okay? It's not that difficult. Alright, here we go. Now, lastly, let's look at the end characteristics of polynomial graphs. Okay? The end characteristics. Before we start, let me say a couple of things about this material that we are about to look at. First, it is really easy to understand and do, because right now you can look at your notes to help you, so it's not difficult. It's actually amazingly simple. However, on the quizzes and tests, you will need to have the information that I'm about to give you completely memorized. So in that regard, it does become a little difficult, so make sure you learn this material. Okay, here we go. Now, before I get into this, I want to say something to you. Well, let me cover that in a second. Let's continue on. We are going to look at 4 scenarios, so be ready to label these in your notes. 1, 2, 3, and 4. Here's the first scenario. Write this down, please. Scenario number 1. When the lead coefficient is positive and the degree is in your notes, please. I'm going to kind of ramble while you're doing that. We have not talked yet about what lead coefficient is. Let me explain that to you now. I would take some good notes on this, okay? Students sometimes become confused and look at the first coefficient and say, oh, that must be my lead coefficient because it's in the front. And they're right in a way, but here's the thing. Never try to figure out the lead coefficient, in my opinion, until you've written it in standard form first. Alright? I would always write the polynomial function in standard form first. So it goes like this. Here's your highest exponent. Here's your next highest exponent. Here's your next highest exponent. And here's your constant term. Now, let's do this real quick. Let's make this a positive 6 in your notes, please. And let's make this a 4. Okay? Make that a positive 6, please, and make that a 4. There we go. Okay, now, after you've written it in standard form, here's your lead coefficient. And here's your degree. Now, you might say, Mr. Earhart, I don't need to write it in standard form. I can look and find the highest exponent and know this is my lead coefficient and this is my degree. And to that I say no problem. I have no problem with that whatsoever, okay? If you could do it that way and save yourself time, no problem. But understand the lead coefficient is the first coefficient after the polynomial function is written in standard form, okay? So either you're going to write it in standard form or you're going to look for it and find it on your own, okay? So in this situation here, notice my lead coefficient is what? Positive. Notice my degree is 4, so it's even. So if I were to graph this function, that means to the left and right it will go up. So it'll go up, and it might take a bunch of turns, okay? But then in the end it'll go up again over here. Isn't that helpful to know, guys? It's so helpful to know that the polynomial you're graphing is going to take a certain, in fact, actually, what's the degree of this? It's a 4th degree, right? Everybody got that? So we know it's going to take a max of how many turns? 3, because you subtract 1 from the degree. So we know it's going to take a max of 3 turns. 3 turns, okay? And we know it's going to go up to the left and up to the right. So you would actually know how many turns this thing is going to take, or at least the maximum number of turns that can happen. Now, students, here's the deal. I want to be very clear about some stuff, and I hope you will listen to me, okay? I've taught this for years, and I know where students get confused. I am not saying to you that the graph will go up over here in this quadrant. It's not what I'm saying. The entire graph might take place over here. It might look something like this. There you go. And of course it continues up and continues up. I'm just saying the left part of the graph will continue going up, and the right side of the graph will continue going up. This graph itself could be anywhere. It could be here, or here, or here, or the whole thing could be over here. But to the left, it'll go up and never come back down again. And to the right, it will go up and never come back down again. Okay? So you need to memorize this and know this. When does this happen? When the lead coefficient is positive and the degree is even, that's when it happens. Okay, let's look at scenario number 2. When the lead coefficient is negative and the degree is even. When the lead coefficient is negative, please write this down. When the lead coefficient is negative and the degree is even, the left and right ends will go down. The left and right ends will go down. So if our function looks something like this, maybe you want to write this in your notes. That is a 6th degree polynomial function, and even though you can't see it, there's a negative 1 right here. So your lead coefficient, well, first of all, is it written in standard form? Yes, it is. So your lead coefficient is negative 1, and your degree is 6. So my lead coefficient is negative, like it says right here. go down and the right side will go up. Okay, so please copy that in your notes. I'm going to continue on like I always do. If you can listen and copy it down, that's fine. If you want to pause the video, that's fine also, okay? When the lead coefficient is positive and the degree is odd, the left side will go down and the right side will go up. So let's say our function looked like this. Five x cubed minus 7. Is that written in standard form? Yes, it is. My lead coefficient is 5. We call that positive. So positive 5. My degree is 3. We call that odd. So when the lead coefficient is positive and the degree is odd, then the left side will go down and the right side will go up. There you go. Now, there might be some terms in here, there might not be, okay? But you know that in the end, to the left, it'll go down. It won't come up again. It won't make it. It will not make another turn. And to the right, the graph will go up and it will not come down again. It will not make another turn. Of course, this could happen anywhere. The whole thing could be over here on the right side of the coordinate plane. It could be all up here, down here, over there. It's irrelevant, okay? But in the end, it'll continue going down to the left and up to the right. These are real important, quick little secrets, or not secrets, but quick little characteristics you can find quickly that will help you graph these once we get into graphing these. And then lastly, please copy this in your notes. When the lead coefficient is negative and the degree is odd, the left side will go up and the right side will come down. Please copy that in your notes. Now, here's an example while you're doing that. There is a polynomial function. It's written in standard form. If it was not written in standard form, don't forget to do that first. But anyways, here is the polynomial function. Now, here's your lead coefficient. Here's your degree. Alright, notice my lead coefficient is negative. Notice my degree is 7 odd. So my lead coefficient is negative, my degree is odd. The left side will go up and the right side will go down. Now there might be some turns in between here, but in the end, we know it'll go to the right, it'll go down, and it will never turn again and come back up. And to the left, it'll go up, it'll never turn, it'll come back, it'll never turn and come back down. And by the way, these are not straight lines. Okay, they look like it, but no, they're curving also. They're coming up and curving and continue going upward. Same thing here, it's not a straight line. Okay, nowhere on a polynomial function will you have a straight line. Nowhere. Okay, curved, rounded, turns, and shapes, okay? So to the left going up, to the right going down, when your lead coefficient is negative and your degree is odd. So really with your notes open, this material is simple. You simply just look at what scenario you have and match it up with the proper characteristics. But when it comes to a test or a quiz, you're going to have to know this information. Now, let me see if I can summarize these 4 scenarios for you on one page, okay? Lead coefficient positive, degree even, we're going to have up and up to the left and right. Lead coefficient negative, degrees even, we're going to have down and down to the left and to the right, okay? Lead coefficient positive, degree is odd, we're going to have down to the left, up to the right. Lead coefficient is negative, degree is odd, we're going to have up to the right, up to the left, down to the right. And that's it, guys, okay? So not really a lot of tough information today, just stuff you gotta memorize. And don't forget, because when we get into graphing polynomial functions, I'm gonna really expect you guys to know this, so we can graph these things pretty quickly and use these shortcuts / character traits, okay? Guys, I hope this video's been a help. If you have any questions at all, never hesitate to contact me.